I feel welcome again for this short presentation. I believe the topic, the shorter coverage that I want to undertake is on solving a linear programming problem. In the previous video, I actually provided an introduction on what are the linear programs and how to solve them. That is the procedure of solving them. So I'm just going to provide a short example to enable you to understand more on this problem and how to solve the linear programming problems. So I've given a short question there which talks of find the maximum value as well as the minimum value of c equals to 3x plus 4y. For this case, we are calling it the objective function or quantity, subject to the following constraint. The first one is x is greater or equals to 2, and then the second one is x is less or equals to 5, and the third one is y is greater or equals to 1, and the last one is y is less or equals to 6. All these four are called the constraints. So I've actually on the left hand side tried to draw those inequalities. The first one being x is greater than 2, I've drawn a line through 2 and shaded the lower part because we require the region which is greater than x. Then the second one is x less than 5. I've drawn a line through 5 and shaded the greater part. And then the third one is y greater than 1. So I've drawn a line through y equals to 1 and shaded the less one. And then y equals to 6. That is y less or equals to 6. I've drawn a line through y and shaded the greater part. So there's a region remaining here, which is the required region. So in the previous video, we said that we need to read the values of the vertex. So you can see this required region has four vertex, as you can actually see, which are 2, 6 here, then 5, 6, then there's also 2, 1, and the last one is 5, 1. Then what we need to do is now to evaluate the objective function at the vertices. So I've said this one, the objective function is given by 3x plus 4y at each vertex. So I'm starting with 2, 1. At 2, 1, the objective function by substitution goes to 10. Now at 2, 6, by substituting this one, the objective function goes to 30. Then at 5, 1, that is the third vertex, the objective function goes to 19. Then lastly, at the 5, 6 vertex, the objective function reduces to 39. Now, if you are to compare these values that I've gotten at the vertices, then you realize that 9 is the largest and 10 is the smallest. So for this case, therefore, 10 become the minimum value of C, and 39 becomes the maximum value of C. And therefore, you can note this one, that the minimum value of C is 10, and this one usually occurs where the x is 2 and y is 1. That is the point 2, 1. Similarly, the maximum value of C is 39, as you have seen from that calculation, which occurs when x is 5 and y is 6. That is at the point 5, 6. And therefore, we can write this one, that C is going to be less or equals to 30, but greater or equals to 10. That means all the values of C are going to be bounded between 30 and 10. That means 30 is going to be the maximum and 10 is going to be the minimum. Any other value that will be calculated along this region C will just be in between 10 and 30. So I believe by that demonstration of that particular question, you can be able to solve a number of questions that are related to these linear programming problems. Thank you and be blessed. Follow me for more videos. to come. Thank you.